Hello students, and welcome to your last video in the G1 series. In this video, we're going to be talking about a topic called deductive reasoning. Let's begin. Deductive reasoning is a type of reasoning or a type of logic that's based in fact. A type of logic or reasoning based in fact. And since geometry is all about postulates and theorems and definition and facts, that's the type of reasoning we're going to be studying today. Usually, deductive reasoning takes a proven, generalized statement to form a specific conclusion. So you'll be working from a general concept towards a specific conclusion. There are two laws that we're following in this study of deductive reasoning. The first is called the law of detachment, and look at that word. Within the word detachment is the word detach. Okay. So there are two premises, which are just statements that are accepted as true, and a conclusion. So three separate statements, and they must follow this pattern. Let's go back to our P's and Q's. Let's say we start with a conditional statement that is true. The next statement takes the conditional statement and detaches it into a basic statement about the hypothesis, followed by the final conclusion of the first statement. So let's see some examples, because I know that's confusing when it's all in letters. Ready? I've got some colors here to represent P's and Q's. If an angle is less than 90, if an angle is less than 90, there's my P statement, then it is an acute angle. Then it is an acute angle. There's my Q. Now, first, let's think about that. Is that a true general fact? If an angle is less than 90, then it's an acute angle. That is true. I'll put a T over here for true. All right. If I pull out my protractor and I measure angle ABC to get 43 degrees, that's part of this P statement. This angle is 43 degrees, which is less than 90. So this is a specific angle that we're looking at, but it's a specific angle that is less than 90 degrees. Therefore, I can make a statement about angle ABC. Therefore, angle ABC is an acute angle. Which is back to this Q idea. So let's look at that again. General statement. If an angle is less than 90, then that is an acute angle. That's our definition of an acute angle. Well, angle ABC was measured to be less than 90. Therefore, we know that angle ABC is an acute angle. We have taken this original statement and detached it right through the middle to form two other statements. All right, let's see another example. If a quadrilateral is a parallelogram, then its opposite sides are parallel. Let's get our P's and Q's. If a quadrilateral is a parallelogram, then its opposite sides are parallel. That's our general statement. That is the definition of a parallelogram. Well, now we're looking at the specific quadrilateral. Quadrilateral ABCD is a parallelogram. Okay, there's that P statement again. Parallelogram, parallelogram. So we're following this pattern of detachment. We started with an if-then statement. If the quadrilateral is a parallelogram, then its opposite sides are parallel. The specific quadrilateral we're talking about is quadrilateral ABCD, and it's a parallelogram. So therefore, we know that ABCD has opposite sides that are parallel. And that would be our Q statement. So let's follow through one more time. If P, then Q. Our P is all about parallelograms. Our Q is all about opposite sides parallel. The specific parallelogram AB, or the specific quadrilateral ABCD is a parallelogram, back to our P statement. So that gives our final conclusion, ABCD has opposite sides that are parallel, as our Q statement. We're just following this pattern of detachment, detaching the definition to build two statements. Last one. Let's give it a look. Every Thursday is Chicken Nugget Day at SHS. That is a true statement. Every Thursday here at Salem, we serve chicken nuggets in our cafeteria. A true statement. All right, so the conditional would be if it's Thursday, okay, there's the P statement, then it's Chicken Nugget Day. There's the Q statement. Every Thursday, it's Chicken Nugget Day. Well, on April 6th, it's a Thursday. That's a specific day of the month. That's back to our P statement about Thursday. Therefore, I need something here about the Q statement. I need something about the conclusion that's also about April 6th. So what do we know about April 6th now? If every Thursday is Chicken Nugget Day at SHS, and April 6th is a Thursday, therefore, April 6th, SHS will serve chicken nuggets. I hope this concept of detachment is really standing out to you. We're taking our original if-then statements, detaching them right at the break, and building two separate statements out of it. So this pattern up here, super duper important as we move on. All right, let's look at a new law. Let's look at something different, a different pattern. Check out the law of syllogism. With the law of syllogism, there are going to be three parts. So let me grab another color here. Okay. With the law of syllogism, there are two premises or two statements that are accepted to be true and one conclusion. Let's see what they offer. Here's our pattern. If P, then Q is going to be followed by another if-then statement. Now look at this pattern here. The Q is going to repeat. If P, then Q, statement one. If that Q stays the same, then we'll get a new conclusion called R. And we're going to follow that up by linking P and R. Q is the middleman. So we're going to link up P to R. Q is going to be the connector. Let me show you a few examples. Check this out. If it continues to rain, all right, so then that's my P statement about rain. If it continues to rain, then the soccer field will become wet and muddy. Well, if the soccer field becomes wet and muddy, then the game's going to be canceled. All right, so just use your logical reasoning here. If it keeps raining, the field is going to be muddy. If the field is too muddy, then the game's going to be canceled. So what can we link together? Because this Q statement has been doubled up, we can link the P statement to the last R statement. So we're going to have a conclusion that matches statement number one. A hypothesis that matches statement number one and a conclusion that matches statement number two. Let's put it together. If it continues to rain, then the soccer field will become wet and muddy. If the soccer field's wet and muddy, then the game's going to be canceled. So, if it continues to rain, what's going to happen? The game will be canceled. The statement about the soccer field being wet and muddy is eliminated because it's already done its job. It's linked up these other parts. Let's see a couple more examples. If the bank robber steals the money, then the sheriff will track him down. And if the sheriff tracks him down, then the bank robber will get arrested. So let's put it together. Original hypothesis. If the bank robber steals the money, then the sheriff will track him down. If the sheriff tracks him down, there's your repeat statement, then the bank robber will get arrested. So our logical conclusion would be, if the bank robber steals the money, then he will get arrested. This repeated piece about the sheriff tracking him down is not necessary to add in there. All we have to do is take the original hypothesis about the bank robber stealing the money and link it up to the final conclusion about him getting arrested. Final example. Here's a math example for you. If two angles are vertical, then they're congruent. And if two angles are congruent, then their measures are equal. Okay? So let's come up with our final conclusion. If two angles are vertical, then they're congruent. We know that to be true. If two angles are congruent, then their measurements are equal. We know that to be true. Those are two true statements. Well, we don't need this middle piece about being congruent. We can link the first piece about being vertical to the final piece about the measurements are equal. So our final statement is, if two angles are vertical, then their measurements are equal. Check out this pattern one more time with me. If P, then Q. If Q is repeated, we have an if Q, then R statement. The law of syllogism says that you can connect the original P to the final R. That makes this pattern another very important pattern for you to know. You guys, these two patterns, the law of detachment and the law of syllogism, are not on a formula sheet anywhere. These are logical ways of thinking that make valid conclusions. On the back of your note sheet here, you have a practice set of problems. Use your examples that are given to you and see what you can do. When you're done practicing, bring them up and I'll check them for you. Happy studying!